Okay guys, I know we're staying home right now and we're not able to get in class, so I wanted to give you some of our math lessons so we knew what we were doing and not just guessing on it. So this is lesson 7 in your Saxon Algebra 2, talking about percent and equations from geometry. Now the percent is pretty simple concept. But when you first look at it, it looks a little difficult. We don't want to make it difficult. We want to make it as easy as we possibly can. And I remember what it was like being in school and looking at algebra and thinking, man, this stuff is rough. How am I going to remember all of these formulas? And so we want to make that as easy as possible. And so instead of remembering several different formulas, what we're going to do is just focus on one formula that will help us with all the formulas that we have to memorize or have to remember. Now I'm looking at this, I hope you can see what's on the board well, but if you can't, if you get your book, have it open just like you're in class with me, follow along, and then you'll be able to see what I'm talking about. So if we look at the page there, this will be page 46, you're looking at lesson 7. Right as it starts talking about percents, we're not just talking about how to get a percent or how to gain a percent or calculate a percent necessarily, but they're giving us some specific formulas for that. And our book points out, and come this side, points out 3 separate formulas. Your book says WF times of equals is, or what fraction times of equals is, and it says P over 100 times of equals is, or part divided by 100 times of equals is, and then P over 100 equals is over of. Now, all of those formulas are great, all of them work, but the problem is they're difficult to remember. And so what I remember doing in high school, or what my mathematics teacher gave me in high school to replace all of these was one simple formula. And that formula was part equals percent times the whole. Part equals percent times the whole. And that one formula can really take the place of all of these formulas and make it a lot easier to remember. And so instead of having maybe a tool bag that's kind of cumbersome or laborsome with 3 different formulas that would be hard to remember, we have one multi-tool for that particular formula. You say, well, Chad, how is that a multi-tool? If we have part equals percent times the whole, then instead of saying, you know, I need to remember my formula for percent, instead of having to go back over here and find it, what I can do is just use some basic algebra. And I can say if I need to get percent by itself, and now this one's kind of our base equation, part equals percent times the whole, but if I'm looking for the percent, how do I find that formula? Well, we use some basic algebra. And in doing so, I'd say I need to get percent by itself. Now, how do I do that? Well, if I divide by W on both sides, my W's will cancel here and here, and then I'll have percent equals part divided by W. And I can do the same thing if I'm looking for not the percent, but if I'm looking for the whole. What I would do is get rid of those W's there. I would get W by itself, divide by percent on this side, divide by percent on this side. So my W is going to equal part divided by the percent. And so instead of having to remember all of these formulas or write down all those formulas, I'm using one base formula, and I'm making that formula work for me by using basic algebra that we've learned over the last couple of years. This is going to make life a whole lot easier. So instead of trying to remember all these, instead of writing all these down, let's write down this one formula. P equals percent W, or part equals percent times the whole. And then we can make it work for us this way. So what I'm going to do now is, instead of having all this, I'm going to go ahead and rewrite what we did here. Part equals percent times the whole. Percent equals part divided by the whole. And then whole equals part divided by the percent. All right, I'm gonna go ahead and erase this and use this as our work blank right here for, let's go ahead and work out 7.1. This is example 7.1. 7.1 asks the question, or it says, it makes a statement, 18 is 20% of what number? Now there's a few things that we need to kind of look at whenever we're paying attention to these, whenever we're reading over these. There's some keywords in there. So we notice the word is and of. Is going to help us denote the part. Of is going to help us denote the whole. So if you're reading through these problems and you're having a problem saying, man, I don't know, I understand the formula, I just don't know which number is the part, which number is the whole. Well, if you look for the keywords is and of, we can see which is the part, which is the whole. In our example 7.1, it says 18 is. Well, 18 is, that's going to be our part. So 18 is the part. And then it says 18 is 20%. Well, that's pretty easy, the 20, because it says 20%. So we know what that is. Then it says of what number? We don't know. So the of is the whole, but we don't know what that is. So if we're looking for the whole, we don't know what the whole is, then we come over here and decide what formula we're going to use. Well, whole equals part divided by the percent. In this case, if whole equals part divided by the percent, we can say it's going to be 18 divided by 20. 18 divided by 20. It's going to go into 9 times right there. Of course, it's 0.9 right now. We understand that, but this is 20 going in again into 18. So in other words, for us to figure out what number that is, we have to multiply that by 100, getting us to 90. And so 20 will go into 18, that 0.9 times, getting us back to 90. Very simple way to use the formulas. We don't want to make it any more complicated excuse me, than what it is. It kind of work the same way in 7.2. 1500 is what percent of 250? So 1500 is what percent of 250? Again, we're looking for what percent. So we know we're going to have the formula percent equals part divided by the whole. Well, what is our part? Well, 1500 is what percent of 250? Now this one can be a little tricky because our part 1500, because it says 1500 is what percent of, that's the whole, of 250. Now you notice right away that the part is much greater than the whole. Now we won't have to go into a lot of explanation of this, but we have learned in the past that we can have a greater part than the whole. We won't go into why that is right now, but we can certainly explain that at a later time. So how do we figure out percent? Well, percent equals part divided by the whole. 1500 divided by 250. Well, 250 is going to go into 1506 times. And we know that to be so. So not only does it go into 6 times, but we have to multiply by that 100 to get it into percent. And so it's going to equal 600%. And again, you can see this kind of basic worked out in example 7.2. Now, if you've had me in the class, you had me in algebra before, the last one we talked about using single bubbles like this and using the whole and the parts. If you recall, when we have greater than 100%, we use what we call a double bubble. And so I just use this for my explanation. I think Saxon actually teaches it this way as well, at least they used to in their books. But we have a double bubble for any percent that's greater than 100. And this is just for us to see, and that's for us to use as a visual representation. And so this, a lot of people don't like to draw things out like this, but it will help you if you use those bubbles. If you're not familiar with the bubbles, you can let me know, and we'll go back over those and show you how to use those at a future date. But again, just to recap real quick, using our part equals percent times the whole, that formula, for both of those examples that we worked out, this base formula is going to be the easiest for us to use. And remember that formula, then we can use algebra to work out the other parts of the formula. All right, we're going to go ahead and move on and look at now some equations from geometry. And these are extremely basic as well. We're going to see in 7.3 a triangle. Now, if we remember from our previous lessons in basic, again with geometry, we know that every triangle, doesn't matter what it looks like, whether it's an isosceles, whether it's a scalene, whether it's an equilateral or equiangular triangle, every triangle has how many degrees total on the interior. When I say total on the interior, I mean if I were to, let me get a different color marker here, if I were to add this angle plus this angle plus this angle, what would that total number be? What they're looking for. Are they looking for a particular angle or degree right here? No, that's not what they're looking for. With this particular problem in 7.3, they're looking for what is x. Say, well, how in the world do I figure out what x is? Let me put my degree sign there, I forgot. Well, it's very simple. This whole thing right here, 2x plus 2, that's what a is in degrees. 7x plus 18 is what b is in degrees. 6x plus 10 is what c is in degrees. And so what we're going to do is we're going to say 2x plus 2 plus 7x plus 18 plus 6x plus 10 equals 180. Now that may look a little confusing right off the bat, but it's not. It's going to get there, and it's going to be a lot easier than what you may think. So what do we do from here? Now recall that if we're adding, we have a variable, we're going to add like terms. So in this case, we're going to add the 2x, the 7x, and the 6x. Well, 2 plus 7 is 9. 9 plus 6 is 15x. And then we're going to go ahead and add the 2, the 18, and the 10. 2 plus 18 is 20. 20 plus 10 is 30. And that equals 180. Okay, so our goal is to solve for x. So how do we solve for x? Remember, the main goal is to get whatever we're looking for, whatever variable we're looking for, get it on one side by itself, get everything else on the other. So what I'm going to do is I'm going to take this 30 and, like what we like to say in class, is change sides, change signs. So the positive 30 crosses the equal sign and becomes a negative 30. So now we have 15x equals 180 minus 30, which is 150. And so we can probably already tell or see what's going to happen at this point. Now remember, we're still looking for x. So what do we need to do now? What's happening to x to get 150? Well, x is being multiplied to 15 to get 150. So how do we figure out what x is? Well, we do its inverse operation. We're going to divide by 15. And remember, when we divide an equation, we can't just divide this and that's it. What we do to one side, we have to do to the other. And so divide by 15 here, divide by 15 here, x then equals 10. So we see how we solve for x through this problem here. There's some things you have to know. You have to know that there's a total of 180 degrees for each angle when we add all those together. And then once we know that, well, we can say, well, this angle plus this angle plus this angle equals that 180. whittle it down from there, add like terms, and get x's on one side, everything else on the other, and then just divide out the number that is being multiplied by the x, and then we'll get down to our answer. Okay, we're going to look at 7.4 now. 7.4 introduces, what does it introduce? We've already seen what we've learned to call transversals. Do you remember what a transversal is? Transversal is a straight line that intersects two parallel, at least two parallel lines. Now in our case right here, we have 1, 2, 3, 4 parallel lines. Now what's interesting about a transversal, which you've already learned, is that whatever angle this transversal makes right here, makes the same angle here, the same angle here, and the same angle here. And we've also learned that if this angle is whatever degree it is, or in this case 3x degrees, then this vertical angle is going to be the same as well. Okay, that being known, if we know that this angle right here is 3x degrees, what does it mean this angle is? That's right, remember they're all the same. Here, 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 and here are all the same, so this angle also has to be 3x degrees. You say, well, how does that help us? Well, it gives us a platform to solve for x. You say, well, how does it give us that platform? Because we know that this angle right here is what we call a straight angle. And what is a straight angle? From this all the way over here, just completely flat, completely straight, how much is that angle? Well, we know it to be 180 degrees. I hope you can see at the bottom right here. If not, just kind of pay attention, follow along the best you can. We know that from here to here is 180 degrees, or 4x plus 33 plus 3x equals 180. So we do the same thing as we did up here. We're going to combine like terms. Well, 4x plus 3x is 7x. So 7x plus 33 equals 180. Sorry for the sloppy writing right there. Now what we're going to do is get x by itself. How do we do that? Well, we have a positive 33 right here. Change sides, change signs. So now we have 7x equals, let's say 147. 7x equals 147. Well, now what do we do from that point? Solve for x again. We do the inverse operation. If 7 is being multiplied to x, let's undo that, unlock it. We'll divide by 7. So 147 divided by 7, yeah, x equals 21. And that's not too hard to figure out, but we understand, I guess, what we may have missed if you were just staring at that real quick. What we may have missed is that the 3x here is also the 3x here, also the 3x here, which also makes it the 3x there. So once we get that, then we know that a straight angle is 180 degrees. And so from there, it's pretty simple to solve. Let's look at that last example problem, 7.5. 7.5. And they give us a straight angle and have some rays off there telling us really, when they give us A, B, C, and D, they're really talking about this angle, this one, and this one. Okay, that's what they're talking about and telling us. Now, I know they're not exactly to scale, but you can get the idea. This is A, B, C, and D. And then they're not numbered like this, 1, 2, 4, 2 in your book, but it does tell us in the reading. It says the measures of angles A, B, C, and D are in the ratio of 1 to 2 to 4 to 2. So they're the ratio of 1 to 2 to 4 to 2. You say, well, how does that help us out? How are we going to figure that out? Well, it's, again, pretty simple. What we need to do first is, again, realize that the total degrees of this whole thing is what? Back to that old number, 180. And say, okay, still, if we know that whole thing is 180, how does that help us out? Well, that ratio does it for us. 1 to 2 to 4 to 2. A is going to be 1x. B is going to be plus 2x because it's at a ratio of 2. What's C going to be? Yep, it's going to be 4x. And D is going to be 2x. So it goes just like the ratio, 1, 2, 4, 2, 1, 2, 4, 2. So 1x plus 2x plus 4x plus 2x equals 180. So let's go ahead and combine those, combine like terms. That's pretty easy to do because they're all x's. 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 2 is 9. So we have 9x equals 180. And again, solve for x, easy to do, inverse operations. Let's divide by 9 on both sides. And so x equals 20. And so what are the degrees of each one of these? Well, A is going to be 20 degrees. What's B going to be? Well, it's in a ratio of 2, so it's going to be 2 times 20 degrees, which equals 40 degrees. C is 4 times 20 degrees, which is 80 degrees. And then D, again, is 2 times 20 degrees, which is our 40 degrees. So pretty simple to figure out at that point. Just to recap real quick, we talked about the percent. Go back and use this formula, P equals percent times the whole. If you grasp onto that one, use that as your multi-tool. That's going to be way, way easier than trying to remember all those other ones. Don't forget that we can't have a part greater than the whole, and if the part is greater than the whole, whatever percent we get is going to be greater than 100%. Then when we're working out our geometry here, just to recall that every angle inside a triangle, if we add those up, it's going to be 180 degrees, and then we can add whatever those degrees are they're telling us. With our transversals, don't forget that whatever angle we make on one, it makes the same angle for each transversal. And then right here, that straight angle, again, is going to be 180 degrees. And then when we get to this, something that looks like this, whatever ratio they give us, we're just going to multiply that ratio as x. 1x, 2x, 4x, 2x. Then, of course, it all equals 180 degrees. Good luck with this lesson. If you have any questions, any problems at all, let me know. We'll answer those just as quickly as we can.